Okay, for this you need a sheet K5a, and we are investigating a phenomenon called refraction. All you need is your ray box connected to your power supply, single slit and a glass block. And we're investigating what happens as the light passes into the glass block. You can see the light is actually bent by the glass block. A bit like this, you might be able to see it a bit better. You can see the light gets bent, and if you get the angle right you can actually cause the ray to be totally internally reflected. We'll learn about that later, but anyway, the first thing you need to do is draw on, use your graph paper and line it up with the lines on the paper. You draw around it like this. Okay, and then you need to decide where your normal line is going to be. So take away your block, draw a normal line at 90 degrees to the surface of the glass block, or we call it the interface between two mediums, one medium being the air and one medium being the glass block. Label it on your diagram: glass block. This is air, this is air. Okay, look at my diagram. This is the normal line here, and it's at 90 degrees to the surface. Right. So again, I can draw my symbol to show it's 90 degrees. That angle in there is 90 degrees. It's perpendicular, we call it. Two things are perpendicular, right angles. And the second thing I need to do is draw a line at an angle of 20 degrees, because that's the angle that we want the incident ray to come in at. It needs to be at 20 degrees. This angle in here needs to be 20 degrees. So I get my protractor out again. I need to make it so it's 20 degrees between the normal line and the incident ray coming in. So do it like this. Line up the 20 with a normal line like that. Okay, can you see? And then put on 20 degrees like that. Okay, so this angle in here is 20 degrees between the normal and the incident ray as it's going to come in. So here comes my incident ray like this. Comes in like that, and then we line up my incident ray with our diagram to show you that again. So that angle in there is 20 degrees. Okay, line it up like that. So the line is in line with the incident ray. Replace my glass block where it should go, and then I draw on my the ray coming out of the glass block. Okay, so I've just drawn some lines on here. So when the glass block is there, the ray comes out this part here. Now you should be able to work out what happened to the ray when it was inside the glass block. You just need to join this point up here with this point up here. And you should notice that there's a slight change in the angle when the ray enters the glass block. It's refracted towards the normal line. Okay, so it goes in like this and it's refracted this way towards the normal line, and then when it leaves the glass block you can see it's refracted away from the normal line. There's another normal line that you should draw on just here. Okay, so this angle in here is called the angle of refraction. And then I'll just draw another normal line here. Okay, so that completes the diagram. So there's your angle of refraction in there. You need to measure these two and then repeat the process for different angles here. Okay, so you start with a ray coming off here. And so what happens